Time to start.
All right. We gotta go quick. My daughter has a Christmas party that I have to attend. I've been informed. She has informed me multiple times that I have to attend. So we are going to stop no later than an hour from now. We have like 55 minutes or so. Let's get cracking. Okay. Advent of code. We're going to do day 12. Why not search for the chief historian near the gardener and his massive farm? Blah, blah, blah. For each garden plot grows only a single type of plant and is indicated by a single letter on your map. When multiple garden plots are growing the same type of plant and are touching, taxicab only, they form a region. Make sure all my stuff is set. Yeah. For example, okay, this 4x4 arrangement includes garden plots growing 5 different types of plants, A, B, C, D, and E. In order to accurately calculate the cost of the fence around a single region, okay, so we're fencing something. I skipped too much. You need to know the region's area and its perimeter. The area is simply the number of plots. Yep. So E or 3. Yep. D or 1. Right. Okay. It's a square, so it has 4 sides. The perimeter is the number of sides in the region that do not touch another garden plot in the same region. The number of sides of garden plots in the region that do not touch another garden plot in the same region. I'm not sure what that sentence means. The type A and C are each in a region with perimeter 10. Okay, let me see. To me, perimeter is like going around, right? So it's like 1, 2, 3, 4. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So it's the part that's like right around the contiguous area of each letter. Okay. Each plot has 4s. Wait, what are we doing? Each plot. Yeah. Okay, we already read that. Visually indicating the sides of plots in each region that contribute to the perimeter using dash and pipe. Yeah, okay. So they show the area right here. Yep. Plants of the same type can appear in multiple separate regions, and regions can appear within other regions. For example, plants. The above plot contains 5 regions. 2, 3, 1, 2, 3, 4, 5. Yeah. And 4, one big 0 region that's contiguous, and then 4 single X regions. The region containing 21 type O plants is more complicated. In addition to its outer edge, blah, blah, blah. Okay. Due to modern business practices, the price of a fence required for a region is found by multiplying the area by its perimeter. The physicist would like a word. Multiplying area by perimeter, please. These modern business practices need to read about units. The total price of fencing all regions on a map is found by adding together the price of fence for every region on the map. Okay. Yeah, so area 4 times 10 is 40. In the second example, the region with all zeros, it's 21 by 36, 746 for the O's, and then 4 times 1 by 4, right? Part 2 is not easy for this day. The description is funny. All right, I'm looking forward to it. Hopefully I can get to part 2. I think a good goal is to get to part 2 inside of an hour, but we'll see what happens. All right, here's a larger example. Okay, yeah. So, what is the total price for all the regions in your map? Let's see, our map. What's up, Clojure guy? How you been, man? Or late? No, Clojure guy's Alec, right? Yeah. All right. 2024 day 12. Zoom in. I don't think I have a REPL. Zoom in. Okay. Whoop. All right, let's see. Triple click, copy, paste, load that up, and we're gonna start with our normal parse. Stir split lines. Oh my goodness, please hit the paren. There we go. Split lines S. I think we use, wait, map back, right? Parse T. All right. So we have our map. The deal is going to be like the first step has to be, I started making silly mistakes. I definitely need more sleep. Yeah, that's the problem with AOC is balancing this with like the day job becomes a real trick, right? Like it starts to really fill in the extra hours of the day. Right, so we're gonna need to, so given a point, we need to walk around taxi cab like until we get all the points that we can touch. And then we'll have a set of points. We'll know the area, and then how do we calculate the perimeter? Like for a... You could break it into rectangles, but I don't know if that's efficient. Like figuring out if it's a rectangle is kind of a tangential question. We can look for any... Yeah, okay. I think any side that is not bounded by an R, you want to count. Right? So for the given letter that we're on, for like this spot, you say, oh, is this an R? No, that's 1. Is this an R to the, left? No, that's 2. 3, 4, 5, 6, 7. Is this an R? No. 8, 9. You go here. You count this. You go there. So you just got to wander around the whole thing asking, hey, is the neighbor of each spot of each point in your thing an R? And for all 1, 2, 3, 4 neighbors, yes or no, and then sum those up. I think that's doable. So let's start playing with it. Let's see, we have util rect points, right? So we are it's pretty easy for us to wander the whole thing. Now, the one thing I'm thinking is like we don't want to do this. Excuse me. This and this. Like we need to do a reduce where we're building up all the areas, and we can skip any point that's already been determined to be part of an area, right? So we're gonna walk the whole thing, but we're gonna not reprocess this area n times, right? Not that it matters. This isn't so big that we couldn't just reprocess everything, but it makes me feel better, I think. So we're gonna do reduce on this, and we're gonna be trying to build up what areas. Yeah, no, just the set of areas, right? With the key on the left is gonna be a letter, like R, and the R area will contain a set of points, 1, 2, etc. Right? So it's a character on the left and then the set of points on the right. I think we'll do. It's annoying because to skip any points you have to like look inside of here. We could keep another data structure, so we could say areas and then scene to make it really quick to look up, have we seen this yet? That's probably fine. A's, areas, scene. Oh my goodness. As state, and we're going to have a point P, right? And let's see. We want to return scene as S. Well, hang on. Let A is util neighbor, taxi neighbors for our board B. Hey, we just need to board this. Let B is that. The neighbors for our board B for point P. So it's going to walk up, down, left, and right. Ooh, you know what? This scene thing is a bad idea. Wait. I'm kind of going about this wrong. I think we have to. I don't think it matters if it's depth first or breadth first, but we have to recursively search this, right? Once you get to one point, you have to, recursively search starting at that point, get the whole area. Yeah. Which this is close, but might as well start with the function that's gonna need to recurse. So here, let's def in search area or area for board B and point P, right? We get the char is get in board that point, and then we're gonna I think util neighbors, taxi neighbors for the board and the point. I think we need to pass in the character C. I think we need to pass in the character C. So you can start it out like this, but you have to tell it as you go down, hey, you're looking for this, right? So if get in BP equals C. We can just do a when. This is going to be our termination case. Yeah. Right? So when it's equal to C, then we'll keep going. Otherwise, we just return nil, right? And then we can map cat the area for board P and C. Right, so what it does is it returns all the neighbors. Wait. We could do this check right here, I think. We could, before we dive in. P prime. So only get the neighbors that... Okay, for each point, get the neighbors that have that value and then call area on that. And return, mapcat that into what we're doing. I think works. Let's see. So if I say area, the area of parse T 0, 0, starting there. I cannot believe I got this wrong. It's like 5 lines of code. Oh, Stack Overflow. So I didn't properly terminate. That's weird because I'd expect this not to be called rather quickly. Like this should not... Yeah, this is looking for R, right? R gets passed in here, and it should remove... pretty quickly, it should say, hey, there's no more... Let's just see. See how it blows. What it's saying. Oh, I didn't want B. Don't print B. Take that back. Oh, does the taxi neighbors return the self? No. Moves anything off the board. It moves up and down, left and right. Okay. Oh. It's wandering around in itself. Right. So you still have to do like a scene. How do we do that? How do we make sure that we don't just sit in here for forever? I mean, in principle, you could just walk the whole... no. Like, okay, I'm recursing down. I do this. I sit here. I mean, we could keep some mutable state. But how do you do it in like a purely functional way? I mean, you can... If I say scene... But I don't know if this helps. Neighbors. Into seeing that. Right, but I don't know if this helps. Because it's... It only limits some. For a first search, yeah. Yeah, that might be the deal. That's probably the most straightforward thing. Yeah. Yep. Okay. Q is, what's it called? Persistent Q. No. Empty. Is it just a, what's it called? Empty. It's still doing that. Okay. Into that. Get the neighbors. If what let point is peak a Q. If equals get in B point. If equals get in P, get in board P our character, then recur with into Q taxi neighbors of P. I just rebound P, I think. I did. Let's do P prime. P prime. Well, we need to do cond. If there is a P, well, if there is a P, then we're gonna do this. Otherwise, recur with just Q. Otherwise, return. Oh, gotta keep the results. Use a set. Conj res P prime. And this actually needs to be P. I didn't P prime this. Get P prime, get P prime. Conj res P prime. Otherwise recur Q res, right? So the point that we're sitting on is not one of that character. Move on to the next thing and don't do anything. If we're on that character, you know, add its neighbors into the queue and conj in our thing. Otherwise, we're all done and we want to return res. Right? I don't know why I avoid this. Well, I kind of know why. I would rather have a data structure. I mean, I just don't love loop recur, you know? Okay. Oh, we stack. How do you stack overflow? Wait. Yeah, okay. This makes a little sense. I want to try and get it into data instead of a computation, but it's a lot of times not smart. Okay. That did not work. My termination criteria isn't correct, right? Oh, wait. We're still doing the same thing. I'm not preventing anything here, right? I'm not preventing anything here. Is tree seek the answer? Nah, that's gonna wander around forever too. Yeah, we need to keep track of a scene. Right, and no matter what, we're gonna conj. If and wait, let's just cond. There's not a p prime. Oh, you know what I'm not doing? I'm not popping p. And I'm not popping the q. That's one thing. Q prime. That's one problem. Into Q prime. But that's still, I think we're still going to hit the same problem if we do this, because it's still going to go to like 1-1. It's going to taxi neighbors that, and then it's going to, like, we have to somehow not do the same thing twice. And so I do think we want a cond here. If there's no p prime, then we can return res, right? If this point is if scene p prime. Actually, no, I got it. Remove scene, right? When we're putting it into the queue, just remove the things that we've seen before. Wait. And then we need to keep track of scene. That comes before res right here. Conj. Well, scene is conj scene p prime, right? Okay. I did that thing. I think it's running indefinitely now too, but I don't have the patience to go get it. Okay. I mean, I haven't printed them out, but that looks roughly correct. How many? Let's just count. 12, and the answer is 12, right? Please. For ours, it's 12. Yeah, okay. This is getting the area points, right? Is there a better way to do this? I feel like there's a better way to do this, but I'm not seeing it at the moment. To breadth first search a grid and not retrace your steps. Do you have to keep track of a scene like this manually? Anyways, I wonder if there's a way with TreeSeek or something. I'm not sure. Okay. All right, and now that we have the area points, the area is just the count of those, but we need also the perimeter, right? Of the board, it would just be the perimeter. So we're gonna do a similar thing where we're gonna go over the area points actually. APs. I think we can do a simple summation though. Where we return for each point, yeah. Map for this area point, right? We say util neighbors, taxi neighbors for the board and that point. The count that are the count of the neighbors that are not equal to the value of that point, right? Let's just we just get the value each time. It doesn't matter, I think. Get in. Board point. P prime. Not equal to V. Get in board P prime. right? So for each point in the area, get its taxi neighbors, get its value. This is actually repeated. We could theoretically do this once, but let's forget about it right now. Get its value, and count the number of neighbors that are not equal to that value, and sum them. So if we do perimeter, me no like it. Me no like it. Okay, so it got that 3 down here. Well, 1, 2, 3. Yeah. It got that 3. 1, but this one has 2, for example. Wait, no, that's 3. 1, 1, 1, 1, 1, 1, 1, 1. But there should be no zeros. Is there an R completely surrounded by... Let's see, there is 1 0. But we have a bunch. Fudge. We're not including the edges. Let TNs the sum of 4 minus the count TNs. This is a janky way to do it, but I think it'll work. Right? This will return the count neighbors, but there should be 4. If there are 4, then we're not adding anything, right? If there are only 3, then we're on an edge somewhere. And we need to add in 1 because we're on the edge. That looks a little better. Looks a little better. Looks good. Put a little comment here. Accounts for edges. All right. All right. So, def in part 1. Oh, and we're making good time for the board input. We're going to say let APs is area points for board. Oh, that's right. That's right. I think we need to util. You just sum them up, is that right? Oh, no. You have to do something complicated. You have to like... Yeah, you're summing the multiplication of the 2. Okay, so util sum for the util... Oh, but I never did figure out a way to not redo to not do this point and then this point and then this point and then this point, like recursively do that. I mean, they'll all end up in the same with the same answer. I could just ignore that cost, I guess. I think we can do this. What do we want? Like a hash map? Board points, right? Rect points for the board. Go over all the rect points. Oh, but you don't want this because there's multiple areas. So you can't, this data structure doesn't work. Oh my goodness. Do I just ignore this? And just distinct? Just use distinct? I might just use distinct. Because this is going to spit out area points. If I do util sum over the rect points and do the area points for B and percent, right? And then distinct that, I think that technically works. You know, it's not fast, but we're not going to redo the work. Like, we're not going to, you know, duplicate. So get the distinct area points. This is a set, right? And then we need to map APs. We're going to do the multiplication of the count of the APs by the perimeter of the APs. Right? Does this look correct? Oh, that's right. This is used. Wait. I thought distinct. Yeah, no, it has a 0 arg invocation. Oh, this is a map. That's a problem. Okay. Looks pretty good. Looks pretty good. We take those. Parse in. All right. Oh. Maybe this was a worse idea than I thought. I didn't think this was that big. I feel like this spits out an output. I feel like this does say something. It just is slower than I want it to be. I think. Does this not work? Does this not work? Is this that big? I mean, it's kind of big, but like... Ay. I guess what we can do at least is to not do this, but now I'm wondering if, like, something else is wrong. Like, I don't... This ought to be... I should be able to do this for almost anything. I don't think that's the problem. This is like, given a finite set, go over that set. Take 4 numbers for each thing in the set, and then do some math. Like, this is not the problem. I gotta believe that this and this are gotta be the problem. Areas. Let's just calculate the areas, right? We'll do this as a separate step. Get all the rec points. And we're going to keep scene and areas. It can be a set. It could also just be this. Because we're going to keep this in a set, so we should be okay. I cannot believe this is not returning. Maybe I've made a completely incorrect assessment. This is a point P. We're gonna do the let APs is the area points for PNTS, not ponts, points B and P, right? Scene is conj scene APs, not conj into. And areas is conj areas APs. Oh my goodness. Okay, this fixes that. So this would just be going over the areas directly, and then we'll do this, right? Just go ahead and reconnect. I think it's gonna disconnect me. Let's see if T still works with this. Yeah, no, messed that up somehow. I seek from keyword right here. Huh? Oh, that's right. We need to get the. Oh, scheisse, this didn't work. If scene, if scene P, then just return this state as ACC. Okay, if we've seen this point, then return the accumulator. Otherwise, and then we need to get the areas out of that, right? Or we can do that down. It doesn't matter. Areas of the ASs. Okay, let's try this. Reconnect. That didn't seem to take any shorter. If anything, I noticed a blip. Does this not work? Does this approach literally not work? Usually this would work for part 1. Wait, is 1930 the right answer? Is that even the right answer? Yeah. Where do y'all think it's spending its time? In here? I can hear my fan going. Where's... Okay, hang on. We gotta... Y'all can't hear it, but my fan is like freaking out. Which on a Mac, what, M2 I think, isn't supposed to happen. That's a no bueno. Okay. But part 1 parse of T does work. 1930. Okay, that was faster, but I'm guessing this doesn't work. Still. So the brute force the brute force approach doesn't work for part 1. I am deeply suspicious. I feel like I must have done something wrong, except for I am getting the right answer for the test input. An infinite loop somewhere, calc areas just for your input, and you will see. That's a good point. That's probably a better interpretation of what's going on. Let me clear. Refresh. Recalculate. All right. So you're saying, are we stuck in here somewhere, for example? Let's see. Let's see what we got here. For let B is parse and what? No. It gets so mad at me when I do this. Oh. Okay, so yeah, we're not even getting to the meat of it. We're stuck here. Okay. Okay. So let's do area points for board of 0, 0. Can it even do 1 point? Can. Let's say we'll find out which one it's doing just before it does it. $25, 0. 25, 0. I got to figure out this like thread kill thing in the new Java. I think the problem is my Java version. Yeah, like the newer versions of Java don't let you thread kill things. It's really irritating. You can see it like complaining about that. Well, it's unsupported operation, thread stop. So you can't just like stop whatever's going on no matter what. Well, no, did I lose it? 25 and 0, right? Was it 25, 0? Area points B 25 and 0. Let's do 24 and 0. Is there a bug in the scene? Like if... No. Okay, 24 and 0 found this. And then 25 and 0. We expect to be an infinite loop. What do we want to print? P prime? P? Well, no, it's not recursive. I mean, it's recursive, but loop recur. Okay, so it's cycling through. Like it should not do this though, right? The first thing that we do is conj onto scene our new point. And then we never, whenever you're looking at neighbors, you never look back. Maybe we need to do this. Maybe, does it allow you to sit inside of the first view? I mean, we're not in the first view though. I think this is the bug though. I do think this is it. Like, I think... Like, keep it from going back on any of the... anything that's put into the queue, basically. Right? So we put this in the queue. And because P-prom is going in the queue, we put that in the queue, in the scene. And then I mean, I don't think actually we need to do this first. I think if we do this, that's actually totally fine because taxi neighbors doesn't return itself, so you don't need to do that first. Let's try this real quick. No dice. No bueno. I mean, do we have to check scene again? Like, how is it doing this? How is this happening? Where that gets in there, and it gets in there again, and it gets in there again. Like, anytime we put something into the queue, do we need to, right here. I reintroduced the bug. I think that was the bug maybe, but then moving this down reintroduced it. or a similar bug. I think we're there. Area points 25. Nope. What? All right, I gotta go here in just a couple minutes. Like literally just a couple minutes, but print line, P prime, right here. I mean, we could check scene again. Like we could do. Yeah, I'm pretty clueless, so I just don't know what could cause this. We put it in there. The rule has to be anytime something goes in here, it goes in here, right? And so we're putting all these in there. We put all those in here. Oh. Do we need to do this and then put those in the scene immediately? I can't wait to see what other people did. The neighbors. Let's try this. And then I gotta go. Okay, so we'll do this. Like, put these together. Into scene. Into conj scene P prime. So we're gonna put P prime in and all the neighbors we're looking at. This doesn't feel good. And for this one, since we're not looking at any neighbors, we just put in P prime. This doesn't feel good though. This feels like me guessing and not really understanding what's going on, but we're gonna let's just give it a try. This is the last ditch effort before I have to go. Decent ditch effort, maybe? Can I part one of T with these changes? Duh. 1930. Get rid of this print line. Look, let's just run it. Part 1 of N. Give out an answer. Gave an answer. Drum roll. Oh, just in the nick of time. I really gotta go. I am almost running behind. My daughter will be so pissed if I don't show up at her Christmas party. Thank you, everybody, for stopping by. Big dub. Let's go.